there are four equal circles that are externally tangent to each other. This circle, red circle, is externally tangent to these four circles. We want to find the area of red circle in terms of, for example, area of these circles, or in terms of radii of these four equal circles. If you want to have next videos, subscribe my YouTube channel now and turn on the bell. And if you had any question about the solution of this problem or other videos, as I said before, feel free to send a message to my WhatsApp number in the description and comments. Okay, so when we have two circles that are tangent to each other, like for example, let me consider it is tangent, then the centers and this point are collinear. Why? Because if you draw this one, it is basic idea. There are around 50 important ideas that are useful from qualifying level of Olympiad in each country or basic math up to IMO international level. You should know that 50 important formulas. So this one, O1, O2, they are perpendicular to this single line. So they are parallel to each other because they have common points. So they are collinear. O1, X, and O2. So here we can connect these. Let me write with blue. You can connect the centers like this, and let me draw it. It's better to draw like this. This one, and this. Okay. So let's consider it is center here is baby A, B, C, D. So here is what are radius. They are equal circles, R. So each side is 2R. So we can conclude that ABCD is rhombus. So we can say it is parallel to this one, and it is also parallel to this side. Now let's connect the center here. Again, we can say this center and this point, common point, and this center are collinear. I consider the radius of this red circle is D. It is R. You consider it is O. OAB is isosceles triangle because OA equals OB equals B plus R. If I connect O and this point, let me consider this point is X, this point is Y, this point is Z, and this point is W. I can say OX is median, so I can say OX is also, because this is isosceles triangle, OX is perpendicular to this line. And how we can prove these two triangles? We can prove are congruent to each other. So similarly, we can say OY is perpendicular to this side, OZ, and OY. So we can write like this. Now, we want to prove X, O, and Z are collinear. Why? Because OX is perpendicular to AB, OZ is perpendicular to CD, AB is parallel to CD, so you can conclude OX is also parallel to OZ. Because OX and OZ have common points, also we can conclude OX and Z is one line or collinear. You can also similarly prove Y, O, and W. Let's consider it is W. O, Y, and W are collinear. Here, it is 90, 90. It is R. I want to prove that X, B, C, Z is rectangle. Why? Because look, if we have two right angled, and for example, this one, it is R, it is right angle. I want to prove it is rectangle. How? I draw perpendicular from this point to this point, from this point to this line. So it will be rectangle here. It is R, so this one will also be R. It is R, so we understand these 2 points are same. So the main quadrilateral is rectangle. So we conclude this quadrilateral is rectangle. So we can conclude it is 90, it is also 90, it is 90, similarly it is 90. And then we can say what? It is 90, 90, 90, it is also 90. xb equals by, so we can conclude xbyo is square. Because xbyo is square, we can say r plus d is r root 2. Why? It's again one basic idea that if you have isosceles right angle triangle, it is x. So you can say it is x squared plus x squared equals 2x squared, which is x root 2. So we can conclude what? It is r, it is d plus r. D plus r equals what? Equals r root 2. So we can say d equals r root 2 minus 1. Answer of this problem is what? Is pi d squared, because the radius is d. So if we replace here, it will be pi r squared root 2 minus 1 squared, which is 2 plus 1, 3 minus 2 root 2. So we found the area of this red circle in terms of r, which is radius of these four equal circles. If you had any question about this solution or other videos, as I said before, feel free to send a message to my WhatsApp number in the description and comments. Also, subscribe my YouTube channel now and turn on the bell to have next videos.